All right, in this project, we're going to discover a couple of different mate relationships. So this is a public document. The first thing we need to do is make a copy so we can edit this. And then this project already has an assembly in it. So it's already labeled for us, and there are a couple things that have already been connected. You can see over here the different mates that have been created. The most important ones are the rack slider. This one already has a sliding relationship, so we can go ahead and grab it and move it up and down to see that. So eventually we want to have a connection between this handle and this up and down motion. So we have a circular motion that is transferred to a vertical motion by the use of some gears that are inside here. So the other thing, obviously, we can see there's a revolute mate there, and then there's also one inside, which we're going to see in just a second. So with that goal in mind, we're going to go ahead and hide this so we can see the internals. So that is the base, which is the top layer there. Go ahead and click on the little eyeball. And now we can see the inner workings of what we got going on here. So there's already some mate relationships between the handle and the gear on the end of that. And this gear also has a revolute mate, so it spins. And that's the one that comes in contact with the rack slider. So this is a rack and pinion relationship. The gear that is driving or is driven by the rack is called a pinion, so we have a rack and pinion relationship. So we're going to be creating the appropriate relationship to demonstrate how this should work in real life. So the first step we want to do is we're going to reset everything. So I've played around with these, I've been rotating it and sliding this up and down. So I want to reset it to what would be considered the 0 rotation. So I'm going to find whatever mate it is. We'll start with the rack slider and right click it on the left hand side and choose reset. That's going to place it where it originally was. And then I'm going to go ahead and find the pinion revolute, which I don't think I changed at all, but I'm going to go ahead and reset it. And then we're going to reset the drive gear. So we can see now that that rotated back in place. Why this is so important is because once you create the mate, it will assume that's the position you want it to be in for the 0 rotation, or where that starts, that mate starts. Well, I can see here that these gears are not meshed up. And that may not be important for this demonstration of the relationship. So I'm going to try to ignore that and move on from it, but it's going to bother me. But I don't really know how to fix it at this point. So we're just going to ignore that. So the first thing we want to do is create a relationship between the rack and pinion, which is a very special relationship that's up here. So you have these three that we haven't explored yet. We have a gear relation, a rack and pinion relation, and we have used the screw relation before, but it was really glossed over really quickly. But these are all just kind of unique motion dependencies. So for the rack and pinion, we'll go ahead and get started with this one. Go ahead and find that up there at the top. And then the next thing we need to do is choose the mates that are going to be in a rack and pinion relationship. So I'm going to choose the rack slider first. And then I'm going to choose the pinion revolute so that those two are tied together. I'm going to go ahead and move it just to make sure that the direction of travel looks correct. So it does happen to look correct. So as I move this down, in the real laws of physics, this looks correct. The gear is rotating the correct way. Let me show you what it would look like if it was not correct. So in this, I'm going to go ahead and on purpose reverse it and then show you this movement. So that's not how this is supposed to go. It's reversed. So if you ever find yourself in that position, all you simply need to do is click on the reverse direction option, and then it will do the opposite, which will hopefully fix your problem if that's happened to you. All right, so now we have that relationship working out nicely. The thing that's important here is the distance per revolution. So that is referring to the amount of travel up and down that the rack has in relation to the gear. So that would be a very specific ratio or number. So for each revolution of this gear set, you would need to do the math to calculate however many gears there are on this. That's how far the travel would be if you counted the gears on the rack. So the distance per revolution, the math has already been done for me. It's 57.3 millimeters. So the gears should mesh up if they started off correctly, and then they should be matching up for each gear that passes by on the rack. The pinion matches up with that. So it's meshing gears correctly. All right, so we've successfully done this relationship. We're going to go ahead and click the check mark. And so the next thing I'm going to do, I'm going to go ahead and reset the rack slider. And let's go ahead and reset the pinion, which I don't think it's changed. So there we are at the beginning. Now we're going to use the gear relationship. So we have the drive gear that turns the pinion gear, which then drives the up and down of the rack. So I need to connect these two in that gear relationship. All right, I'm going to go ahead and choose the gear option at the top. Then I'm going to choose the drive gear. And then I'm going to choose the pinion. So those are the two that are linked together. So if I turn one, it rotates the other. And it is rotating correctly as far as gears go. So you don't want to reverse. In this instance, we would not be reversing the direction because it's moving correctly. And there is a relationship between the two gears which would involve some math to figure out you would divide on this one you would divide the smaller gear by the larger gear, the number of teeth. And so I've forgotten what that exact number was. I'm going to fast forward here. Went too far. Oh, there it is. So 0.833 is the ratio. So in the ratio, I'm going to put in that number 0.833. So that means for every 0.833, for every rotation of the drive gear, the pinion gear rotates 0.833 rotations because the drive gear is smaller than the pinion gear. Hopefully that makes sense. So now the relationship is correct. So as we're moving in space, we're moving this handle around. It's moving the rack up and down. I'm going to go ahead and click the check mark to accept that. Now I'm going to turn on the base so we can see how this looks as a finished product. And then something that we don't always do, but I like to just demonstrate how this should look, is we're going to go ahead and animate. So you could choose to animate really any one of these relationships. the slider going up and down, or the drive gear rotating, or the pinion revolute. But I'm going to choose, since this would be hand operated most likely, I'm going to choose to animate the drive gear. So to animate, we're going to just right click and then find where it says animate. And then here we have some options. The start value would be when I press play, it would rotate back to the beginning. And with the current settings, this is how it looks. So it's starting at 0 degrees rotation on the drive gear. The end value, it's going to rotate around 360 degrees completely. And then the number of steps, let me go ahead and stop this. The number of steps is kind of like speed. So it's however many steps per, I think per second. So if I wanted it to slow down, I would decrease this. So I could do 30 steps per second. Oh, actually that speeds it up. So if I want to increase it, okay, so that's right. So it divides the travel into 30 steps per second, which would speed it up. If I want to slow it down, I would add more steps. So let's go ahead and do like 900. And then play that. It's not per second, it's total steps. So I'm not really sure how it calculates, time and frames and all that good stuff. So you can really see the travel. And then the playback type is reciprocating. So it's playing forward, and then it goes, once it completes, it will play it in reverse. There are other options here. You can play it one time, so it will just play and then stop. So I go ahead and play it. It's playing through, and it will stop once it gets to 360 degrees. It's done. So if I wanted to do that over and over again, I can choose to loop that. So it would go back to the beginning each time. Let me go ahead and speed this up. So let me go back to 300 was a good number. So it's looping, but it's starting back at the beginning, starting over again. So I do prefer the reciprocate, so it plays it forward, then it plays it backward. It's just more of an appealing, less jolting, looping experience. So that's how you animate. So once you're done with this project, you should be able to see this nice video animation happening here, just to confirm that you did everything correctly. And that is a simple project. You're done.